Hello everyone, I welcome you all to this next video in the Spring Framework lecture series. This video is in continuation to the previous video. If you haven't watched it yet, I recommend you to go check it out before watching this one. In the previous video, I started off the discussion with what type of objects can be considered as beans. Later on, I moved on to explain Spring Beans concepts like bean instantiation, bean lifecycle. In today's video, we will continue our journey of understanding Spring Framework in detail. I will cover following topics in today's video. Number 1. Bean scope. Number 2. Component scanning. Number 3. Beans wiring. Number 4. What can we inject? If you haven't already, please subscribe to the channel, like the video, and share the content as much as possible. Bean definitions are the blueprint or recipe for the Spring IOC container to create bean objects. The idea that a bean definition is a recipe is important because it means that, as with class, we can create many object instances from a single recipe. Bean scope means the scope of the objects that are created for a particular bean definition. The default scope of a bean is singleton. Spring provides us with configuration options in both XML and Java to configure bean scope. To configure the scope in XML, use the scope attribute on the bean element like this. To configure the scope in Java configuration class, use the scope annotation on a method like shown here. Spring IOC container supports 6 different types of bean scopes. Let us have a look at each one of them. Singleton. Singleton scope means that only one instance of the bean is created and managed by the Spring IOC container. This single instance is stored in a cache of such singleton beans. Whenever the bean is requested, the same singleton cache instance is returned every time. The singleton scope is the default scope in Spring. Prototype scope means that a new instance of the class is created every time a request for that specific bean is made. Request can be made in two ways, either if the prototype bean is dependency injected into another bean or using the getBean method of application context. As we can see here, every time an object is requested, Spring will create a new object for the prototype bean. Spring does not manage the complete lifecycle of the prototype bean. The container instantiates, configures, and otherwise assembles a prototype object and hands it over to the client. After the object is returned to the client, Spring does not have any record of the object. This means that initialization lifecycle callbacks are invoked for the prototype object. However, the destruction callbacks are not invoked. The request scope is specific to web-aware application context. Request scope means that a new instance of the bean class is created for each HTTP request. The object is bound to the thread that is serving the current HTTP request. The application code can mutate the state of instance in any way it wants, as these changes are not visible to other objects created using the same bean definition. After the request processing is complete, the bean instance is discarded. The session scope is specific to web-aware application context. Session scope means that a new instance of the bean class is created for each HTTP session. The object is scoped to a particular HTTP session, and we can modify the internal state of the bean as much as we want, as these changes are not visible to other session scope beans. When the HTTP session is eventually discarded, the bean that is scoped to that particular HTTP session is also discarded. The application scope is specific to web-aware application context. The Spring IOC container creates a new instance of the bean class for each servlet context. This means that the bean is scoped at the servlet context level. and stored as a regular servlet context attribute. This is somewhat similar to singleton scope but differs in two important ways. Number one, it is a singleton per servlet context, not per Spring application context. There can be more than one servlet context per Spring application context. Number two, it is actually exposed and therefore visible as a servlet context attribute. The WebSocket scope is specific to WebAware application context. WebSocket scope means that the bean instance is associated with the lifecycle of a WebSocket session. We will learn more about WebAware scopes in the Spring Web MVC lecture series. Let us understand component scanning. What is it and why is there a need for the same? To answer the question of why component scanning, let's understand the pain points without component scanning. In a previous video, we worked our way through the practical implementation of a real-world application. In that application, the number of Spring beans were in single digit, as we can see here. The pain here is we had to manually configure each bean in the Spring configuration. Imagine if the number of beans is in hundreds, the process of configuring the beans and their dependencies will become a tedious and error-prone process. Component scanning is the process of scanning the class path of an application to automatically register and configure bean definitions. To enable component scanning, simply add the component scan annotation on any one of the configuration classes. Now the catch here is Spring wouldn't know which packages to scan or which packages to skip. To fix this problem, Spring provides us options to configure the packages to scan. We can specify the base package name while declaring the component scan annotation like this. If no base package value is specified, the package of the class on which the component scan is declared is considered as the base package. Let's understand a little more about components. Now that we have configured the component scanning, we may feel relieved and happy, but looking closely, we see another issue. The issue is we obviously don't want all the classes present in the base package to be considered as bean. Most certainly, we may have some utility classes or domain classes in our applications which we don't want to be treated as beans. The answer to this is Spring by default does not consider classes as candidates for beans. Spring provides us with built-in annotations that we can specify on our classes to make them eligible for auto-detection. Any classes marked with these annotations act as a source of bean definitions as well as providing the implementing class for that bean definition. Component is a generic annotation for any Spring managed component. Component annotation is a meta-annotation, meaning it can be applied to any other annotations to form more specialized composed annotations. Service annotation itself is marked with component annotation. Service annotation is the specialized form of component annotation. It indicates that the annotated class is a service. Classes marked with repository annotation behave as data access objects. Repository annotation serves as a specialization of component. One would ask, what is so special about them? Classes marked with this annotation make use of automatic translation of SQL exceptions to Java exceptions as provided by Spring out of the box. In MVC terminology, controller annotation is used to indicate any component as being a controller. REST controller is a meta-annotation marked with controller and response body to be used with REST APIs. Controller and REST controller annotations are only supported in WebAware application context. These annotations are commonly referred to as stereotype annotations, and I will use the term stereotype annotations to cumulatively refer to these annotations. We will learn more about them in Spring Web and Spring Data lecture series. Customizing component scanning. All the beans registered with the Spring IOC container using component scanning will have singleton scope. Spring provides us options to customize the beans detected using component scanning. You can specify a string value while declaring the annotation to customize the name of the bean, as shown here in this example. Default SMS sender bean will have the name My SMS Sender Service. If you don't specify any name, Spring will generate the name using a common naming strategy. This strategy is implemented in bean name generator. The default strategy is to generate the uncapitalized non-qualified class name. For example, the name generated for this component would be default SMS sender D with a small case. You can use the scope annotation along with the stereotype annotation to customize the scope of the bean created. Here, in this case, the bean will have prototype scope. This concludes the component scanning chapter. Next is beans wiring. The process of configuring a beans interdependencies is what is known as wiring beans. So far, we have used XML configuration to wire beans. Here, I am using property element to select a class property and using ref element to reference another bean in the Spring container. While injecting dependencies, Spring will invoke the corresponding center method for the chosen class property. For a small application, this process may work, but for a large application having hundreds of beans, it becomes tedious and error-prone. Fortunately for us, there is a solution in the form of autowiring. Autowiring is the process of automatically wiring beans together with the help of some metadata. This is how autowiring works. A class can declare autowired annotation on any field, method, constructor, or setter methods to indicate to Spring to autowire such values from the beans defined in Spring container. Let us have a look at how autowiring works in all such cases. First one is autowired on field. Autowired on field works without the presence of corresponding setter method. When autowired is declared on a field, Spring uses reflection to set the value of the field. Autowired can be applied to any random method in the class as shown in this example. Spring will figure out the method arguments and invoke the method. Autowired annotation can be applied to any setter method as shown here in this example. Lastly, autowired annotation can also be added to a constructor in the class as shown in this example. If a class has a single constructor, we can skip the autowired annotation on the constructor, and Spring by default assumes that autowiring needs to be performed. If the class has multiple constructors, then exactly one of the constructor needs to be marked with the autowired annotation. Let us understand various autowiring modes. Autowiring mode means by which mechanism Spring will figure out the autowiring values to be injected. Spring as default figures out the autowiring candidates by type. In this example, Spring will look for beans of type email sender and SMS sender. If there are multiple candidates for the same type, Spring will throw a fatal exception and application will fail to start. To fix those fatal exceptions, we have two possible solutions. The first one is using primary annotation. If there are multiple implementations of the same interface, we can declare either one of them as primary using the primary annotation, and Spring will use that object to autowire the beans. Next one, we can use qualifier annotation. You can use the qualifier annotation to explicitly refer to a specific implementation by name. In this case, email sender has two implementations, However, Spring will look for cached email sender implementation. Autowiring can also be configured for XML-defined beans, as this example shows. The dependencies of this bean will be autowired using the by-type mechanism. When we talk about dependency injection, one natural question that should come to our mind is, what can we inject? The general idea is Spring allows us to inject any Java object. The Java objects are broadly categorized into three types. Let us look at them in detail. The first one is straight values, primitives, strings, and so on. Spring allows us to dependency inject the Java primitive types, as this example shows. You can also use the value notation to inject primitive types. Value is a powerful annotation, and it also allows us to inject property values from configuration. Autowired only works with objects, so do keep in mind to wrap the primitive types to their object forms when using autowired. As previously mentioned, if there are multiple beans of the same type, this would result in ambiguity, so use qualifier to resolve the ambiguity, or Spring will throw a fatal exception. We will learn more about value annotation in later videos. Next one is references to other beans. Spring allows us to inject objects of other dependent beans. This is what we have been doing for the most part of this course. One important note on this is, if there are more than one bean of the given type, we can dependency inject a list to get access to all beans of the specified type, as shown in this example. Last one is collections. We can define any collection type as a bean and then dependency inject such beans, as this example shows. This brings us to the end of this video. I hope you are able to understand the concepts discussed. As always, comment your doubt in the comment section and I will try to address them as promptly as possible. In the next video, we will see some practical applications of the component scanning and beans autowiring principles. Thank you and keep learning. I will see you in the next one.